Hi everyone. Our present research studies high resolution velocity and temperature measurements in the laminar bound layer of a melting vertical ice phase. As we know, when there is a ice phase is in contact with water, there is a bound layer flow that forms next to this ice water interface. This bound layer flow directly influences the heat transfer from ambient water to ice. Studying this bound layer flow is very important when we are understanding Antarctic ice shelf melting process, which determines future sea level rising. In this study, we developed a methodology to measure velocity and temperature in a laminar bound layer simultaneously. Our experimental setup mainly consists of a water tank and an ultraviolet laser and intensified camera. The methodology that we use to measure velocities is molecular tugging velocimetry, and we use molecular tugging thermometry to measure temperatures. In both the velocity and temperature measurements, we obtain profiles throughout 1 minute period, and we average it within that period, and then we use that time averaged profile to compare it with DNS. After some virtual origin shifting in DNS, we were able to achieve good agreement between experimental and DNS results in both the velocity and temperature measurements. We obtained rough estimate of melt rate experimentally, and when we are comparing those values with DNS results, we were able to obtain good agreement with uh, DNS. Overall, in this experiment, we measure velocity, very small velocities of this bound layer flow, very close to ice water interface. As you can see, these bound layers are very thin. They are in millimeter scales, and we obtain velocities, both velocities and temperatures in this small region. And another most important thing is that we modified standard MTT and MTV techniques so that we can obtain velocity and temperature profiles simultaneously. That means for every velocity profile, we have a temperature profile which is obtained at the same time, which is very important when we are interpreting these results. In the future, we are planning to extend this study to obtain measurements in the turbulent bound layer flow in a bigger setup where the conditions are similar to Antarctic conditions. Thank you very much for watching.